Today, combined gas law, which is right up here, has everything we've done up to this point kind of thrown into one. So you got three things now: pressure, volume, and temperature. But the same exact concept. You're going to be doing the same things. Underlining your givens, plugging in what you know, converting where you need to, and then solving. So I'm going to read it. We'll go through, underline what we know. A balloon has a volume of 810 milliliters at a pressure of 750 torr and temperature -77 Celsius. The balloon is removed from this temperature and allowed to warm to room temperature, so the temperature changed, in a pressure chamber at 3 atmospheres, so the pressure also changed. Calculate the final volume of the balloon. So catalog like we have been: P1, V1, T1, and write down what you know. So you got, for pressure, we got 750 torr. For volume, we got 810 milliliters. And the temperature, -77 degrees Celsius. And then for P2, V2, and T2, we have, so it was allowed to warm up to room temperature, so our temperature changed, 25 degrees Celsius now. In a pressure chamber at 3 atmospheres, so our pressure also changed. And it says calculate the final volume, so that's what we're trying to solve for. So remember from before, the units for pressure have to match up. It doesn't matter what they are as long as they're the same. And for temperature, remember, it's always got to be in Kelvin. So we're going to add our 273 to both of these to convert it to Kelvin. So when we do that, we got, for the first one, -77 plus 273. We get 196 Kelvin. And then on this one, we get 298 Kelvin. And I'm going to convert this one to torr just because I got some extra space here. I could also convert that to atmospheres, so they match up, doesn't matter. As long as they're the same, I'm going to go here. So remember from before, and I'm going to write it up here just because there's some extra space. 1 atmosphere is equal to 760 torr. So 1 ATM, 760 torr. Cancel out. So we get 3 times 760. We get 2,280. 2,280 torr. So now we got units match up. Kelvins are the same. We're ready to solve. So I'm going to do my best to fit it in here. There's a lot of numbers we got to put in, but we'll plug them in, see what we can do. P1 goes there, V1, T1, so plug all your stuff in. 750 torr times 810 milliliters over T1, which is 196 Kelvin, equals, and then plug in your 2's. P2, remember we're using the torr to match up, so 2,280 torr. Volume V2 we don't know, so that's what we're going to leave. And then we have our T2 is 298 Kelvin. So I always say cross multiply when you have these. It'll help you avoid any mistakes and end up hopefully with a nice little equation to solve. So we just cross multiply here, cross multiply here. I'm actually going to do the work down here for you guys so I can do it a little bit bigger. So when we cross multiply here, we get 750, right? 750 torr times that, it's still there, times 810 milliliters. Oops, sorry. 810 milliliters times 298. So there's that cross multiply, Kelvin, equals, we got this times that. So we got 2,280 torr times V2 times 196 Kelvin. So now it's set up nice and neat. You don't have any fractions left. So all you got to do is divide by these two numbers to get V2 by itself. So get rid of this. Remember, you got to do the same on both sides. And then get rid of your 196 Kelvin. So divided by 196 Kelvin. Right? If we divide by 196 here, got to divide by 196 here. And there you go. This is gone, this is gone. So now you got V2 by itself. All you got to do is plug this in your calculator. So on the top, 750 times 810 times 298. And then divide by the bottom. So divide by 2,280 divided by 196 Kelvin, and we end up with 405.1. And it is volume, so it should be liters or milliliters, but if you did all your work, you can see that torr cancels out, Kelvin cancels out, so you're left with that as your unit. So it's actually 405.1 milliliters. All right, if you guys have any questions, let me know. Your job is to do number 2, 3, and 4 down at the bottom. Again, I just put the work here for this one so we could do it nice and big so you guys could see it. All right, see you guys.